Hello everyone, I'm Dr. Dilwar Alam Khan, Assistant Professor from the Department of Chemistry, SS College, Hailakandi. Today, I'm here with my presentation entitled Organic Polymer Based Nanocomposite and Effective Heavy Metal Detoxicant of Wastewater. In this era of civilization, the water pollution due to various factors is a major concern. Certain things responsible for the water pollutions are industrial wastewater. Starting from the industrial wastewater to household activities, or the garbages from the household activities are responsible for water pollution. Also, the municipal garbages accounts for the water pollution. Moreover, the agricultural runoff also contains various pesticides and chemicals which are responsible for water pollution. This wastewater contains certain metals which are very toxic in nature and harmful for human being. Among these, lead is one which is responsible for various diseases. Here we have shown the disease caused, that is decaying of teeth caused by the lead poisoning. Another important thing we can see that this is called agrodynia or the pink disease. This is caused due to the long-term exposure to your toxic mercury ion. Similarly, in our northeastern India as well as the Bangladesh, the problem of arsenicosis is also very prone. So we can see this is caused due to the presence of arsenic in the groundwater. Similarly, pulmonary oedema is caused due to the long-term exposure to cadmium ion. So these toxic metals needs to be removed from the wastewater. For this, various methods have been adopted, just like osmosis, adsorption, coagulation, etc. Among these, ion exchange is found to have certain key features which are very much useful. One of the thing is that it is cost-effective method. Similarly, it is selective as well as specific to certain toxic metal ion. Moreover, this ion exchange material can be regenerated for further use. But we saw from the previous studies that inorganic as well as organic resins, they face some drawbacks. So in order to overcome these drawbacks, scientists have switched over to the nanocomposite ion exchange material. They contain certain useful features like improved thermal and chemical stability, better ion exchange capacity, selectivity, etc. And for this, they are found to have versatile application in various dimensions. Here we have shown the pictorial representation of the ion exchange process. We will now go to the details about it. Just we have taken one example of cation exchanger, and this is your polymeric chain where the negatively charged ion exchangers are attached. So this acts as a cation exchanger. Here we have shown the excited spectrum as well as the same image of one of the synthesized nanocomposite ion exchange material called polyaniline tin-4 iodophosphate nanocomposite. This clearly shows the agglomeration of the inorganic as well as organic part. Now, interesting fact is that when we carried out the distribution studies and found the coefficient value, that is distribution coefficient KD value, we found that among about 14 to 15 metal ions, this particular nanocomposite shown high selectivity towards the mercury ion. Means in every medium we can see that the KD value is very high in case of mercury. So we can certainly say that this nanocomposite is highly selective for your mercury ion. Another interesting fact of this nanocomposite material is that we can also explore various other features of this nanocomposite material. Here we have carried out the photocatalytic study of this nanocomposite material. We have irradiated the methylene blue dye solution in presence of sunlight. So it can be clearly seen that in absence of photocatalyst, in about 8 hours of irradiation, in absence of photocatalyst, a negligible amount of methylene blue is degraded. But in presence of a photocatalyst, here we have considered photocatalyst, that is nanocomposite material, that is polyaniline tin for iodophosphate. In presence of this photocatalyst, within 8 hours of irradiation, about 71% of the methylene blue is degraded. That means certainly we can say that we can use it for photocatalytic purposes, photocatalytic degradation of organic dyes. Similarly, we can convert this nanocomposite material into we can use it in electronic devices if we use electrically conducting polymers as the organic part. So due to the time constraint, we are not going to the details. Here are just the conclusions. That means nanocomposites synthesized by the Sol-Gel method are found to have a very good or improved ion exchange capacity. They are also selective in nature for the toxic metal ions like mercury, lead, cadmium, etc. And we can also explore the electrical conductivity, optical property, etc. for further its use. So finally, we can say that this ion exchange material, that is nanocomposite ion exchange material, has revolutionized this water purification process, and this process through ion exchange method is very much cost effective. It shows fast exchange kinetics, selectivity, etc. So this is all about today's presentation. Thank you all of you for your patience to listen. Thank you. Have a nice day.